Shijil, it should be around a gig, about a gig. All right, guys, I think we have enough participants now to start. Let's go ahead and take a look at today's topics. We are going to finish up on a couple of very important topics today. Again, very important class from the perspective of this particular technology in real life and also from the perspective of the exam. So far, what we have done is pretty much this much in OSPF. You might say you also done metric calculations, which is very basic. You take the whatever your interface bandwidth is and divide it by 10. That's your metric calculation. It's a cost value. It's a simple formula. It's accumulation of all the costs of the links from one end to the other. But we can take a look at, once we do it, you can also take a look at what the cost looks like. Today, we're going to be taking a look at filtering, ACL summarization. We will also take a look at your LSA types 3, 4, and 5. All right, we've done 1 and 2. And in order to do that, I will do multi-areas over here. More than metric calculation, well, I'll put it there, but more than that, my main objective over here is multi-area. With the multi-area configuration, I will be able to show you filtering. And over here, you don't have ACL. I'll show you what the problem with the ACLs is, and then I'll show you the prefix. We'll take a look at summarization. Once we're done with that, we'll take a look at your stub area, totally stubby area, not so stubby area, all those different type of areas. Cool? So what I'm going to do right now is I'm going to set up a topology that will help us do most of these labs. I'll just set one topology up that will be good enough for us to do most of these labs. Yes, recording is on, Puran, and at the end of the class, you get it from Vikas. Is this your first class, Puran? Generally, Vikas will send you the recording of the class. All right, so let's go ahead and do that. I'm going to pull up my GNS over here. I'm going to set up certain routers over here, a particular topology. And this topology, text file you didn't receive, I think I sent it to Vikas. If not, I'll send it again. I'll send both files at the end of this class. R1 to R2. R2 connects to 3. 3 connects to 4. 2 connects to 4 as well. We'll also have a connection to 5 over here. Along the same lines, I'm going to have, and where did it disappear? Oh, it didn't come. So 6, we'll do 7, and we'll do 8. Let's connect the links up. R1 to R2, R2 to R3, R2 to R4, 3 to 5, 4 to 6, 6 to 7. These two over here, I'm going to keep them as serial links. Good. Let's fire the routers up. While it's coming up, I'm going to draw some boxes over here. Make it real nice and fancy. Remove this. Change the color. Actually, this router over here, erase it, is an edge router, so it's going to be like that. Now the color coding over here. I'm going to run OSPF in area 0 over here. OSPF in area 10 over here. OSPF in area 20 over here. This is going to be EIGRP and AS100. Oops. This is going to be RIP version 2. All right. Now the first thing that I want you guys to understand is the concept of areas. Why would I want to have multiple areas versus a single area? I kind of talked about it the last time round. If you remember, we talked about the LSA database 1 and 2. Do you remember that? Within one area, let's just say area, within the single area, all routers will have complete information about the topology of that area. How's that? Do you remember the propagation of the LSA type 1, type 2? Whatever router 1 gets, it sends it exactly as is to router 3. Router 3, whatever it gets, sends it exactly like that to router 5, and so on and so forth. I'm not changing anything. So every router in that particular OSPF area had the same LSA database, which was detailed information, complete/detailed information about the topology of the area, because every router just forwarded the link states to the upstream router. So every router in that area had a complete LSA database 1 to database 2. If you remember from our lecture from last time round, the same network was advertised by multiple different devices. If you remember, we had this type of topology over here. Let me just draw it so we can just recap that real quick. We had a topology where we had 4 routers connected to network 100. This was 192.1.100.0. So all 4 routers actually advertised this network. Now, whose mic is on? All right, so I had this particular type of setup over here. Router 1, router 2, router 3, router 4, everybody connected to 100. And if you remember, each one of those routers sent out an LSA type 1, which was called the router LSA, saying router 1 has network 1 and 100. Router 2 has network 1 or 2 and 100. Router 3 has network 3. I think it had 57. It was connected to 100, plus it has that extra link for, or extra LSA for the verification of the point-to-point link. Do you guys remember that? Everybody okay with this? This is, again, review of a lecture from the last time round. You guys good with this? All right. So this is all the same things that we talked about. Now, what happens is, because of this, the database, the LSA database that has to be housed by each and every router in that particular area needs to have more memory, more CPU utilization, because it's a bigger database. It's a complete database. All right. But the thing is, let's say I wanted to make this database a little less. One of the things that I can do if I want to is I can break it down into multiple areas. Rather than having one big area, I'll keep this as is, but let's say what I want to do is I want to confine this detailed information to this. Let's say this is area 10 over here. Router 5 in turn would connect up to another area, let's say area 0. What router 5 will do is it will keep a complete database, the LSA type 1 and type 2, for whom? For area 10. So on router 5, which is known as the area border router, it will keep a complete database for area 10, because it belongs to area 10. This link belongs to area 10 over here. But at the same time, because it also belongs to area 0, whatever is happening in area 0, it would also have complete information about that. So he would have two LSA databases which are complete for both areas. This is on the ABR. All right. But what it sends from here to here, for example, I have four different networks that are listing themselves as part of area 10. Rather than sending that link multiple times, what router 5 injects into the database for area 0, it says, listen, if you guys want to connect up to network (192.1.100.0/24), just send it to me. So he advertises this particular LSA into area 0. Although it has complete information, R5, the ABR has complete information on how to reach the entire topology of area 10, what it leaks out to the other area is just one particular LSA per network that it has, rather than having multiple LSAs for the same network. Do you have multiple LSAs for the same network for area 10 on R5? Yes, I do. That is just demonstrated over here. If you take a look at this, network 100 is already advertised by 1, 2, 3, then R4 would have advertised it, plus the DR would have advertised the type 2 network to verify, yes, these 4 routers are connected to network 100. This type of LSA, the one that it leaks out to the other areas, so it will send routes from one area to the other. This type of LSA is known as a type 3 or summary LSA. This has nothing to do with route summarization at this point. Why is it called a summary LSA? Take a look at what it did. It took LSA 100, which was listed 1, 2, 3, and 4 times, because all 4 routers would advertise their connections to the link 192.1.100.0, plus it would also have a 5th one injected by the DR, the type 2. You clear on that? So rather than sending 5 LSAs, what am I sending down into the other area? It's just a single LSA. Because it's a single LSA, I'm summarizing multiple LSAs for the same network. This type of summary, and the reason it's called summary is this type of summary is called LSA summarization. You guys okay with that? This is not route summarization. This is just normal LSA summarization, which happens automatically done by the ABR when it injects routes from one area to the other area. Everybody okay with this so far? You guys understand what I'm trying to get to over here? Any questions at this point? Now, in your routing tables, any routes that you see over here, any routes that you see down here in this routing table, if they're routes that were injected into your routing table based on LSA type 1, type 2, that route will be seen as an O route in the routing table, OSPF route. Versus if a route was learned through LSA type 3, it would be known as an O inter-area routes, OIA. In your routing table, you'll see an OIA. It's an inter-area route. Inter-area route basically is telling your router that this route was learned through the ABR. Cool? Everybody okay with that? So who injects, who sends a type 3 LSA into your OSPF domain? What router is responsible for that? R5, but R5 or ABR, whatever you want to call it, both are correct because in our case, R5 is our ABR. Everybody okay with that? Clear? What my objective over here is to set this network up so we can see these databases, type 1, type 2 databases. We'll also see the database containing the type 3, which is a summary LSA for other areas. Okay, let's do that. What I'm going to do over here is I'm going to set this network up based on what we have set up already, but we'll actually configure it now. That is this network over here. If you take a look at this network, I have area 0 in the middle. You have area 10 and area 20. Now, one of the requirements of a ABR is that one of the areas, the router needs to have one connection in area 0, the backbone area. Let me finish this, the note portion of it. To break down a large OSPF database into a smaller set of databases, you break your network down into multiple smaller areas. There's no size per se, although it's recommended not to go over 25 routers in an area. There's no size limitation, and these limitations sometimes also depend on the type of routers that you have. Depends on the type of network that you have. So there's no, you cannot, if somebody says no, you should not have more than 20 routers in a particular area. It depends on what type of routers they have, what type of resources that they're running. Sometimes 3 routers have more networks than 30 routers put together. So again, it depends on a lot of different factors. So there's no right answer. You're looking for a particular number of the number of routers that you should have in an area. You need to monitor your utilization to take a look at it. Nowadays, the routers are robust enough, powerful enough to handle most of the routers. I've seen areas that are more than 50 routers in the same area. Although I would personally break it down because that I lose certain capabilities, and I'll discuss that in a bit. So I'm an advocate of smaller areas, which gives me a little bit more control. We'll get into that in a bit. Guys, your mic speed. All right, so now in order to connect 2 areas, a router needs to have a link in area 0, also known as what? The backbone area, and another area. Another area can be any other area after that. How many areas can you have? Technically, theoretically, 4 billion because it's a 32-bit address. Their area address is a 32-bit address, so if you do to the power of 32, that's the number that you get. That's, again, a theoretical number. So in order to connect 2 areas, the router needs to have a link in area 0 and another area. This router is known as an ABR, area border router. It is not compulsory It is not compulsory. If you had a single area, you can have any area. It doesn't have to be area 0. It's when you connect multiple areas together, you need area 0, because the way OSPF runs it on a hierarchical structure. So in a hierarchical structure, you have to have one single area at the top. That's the main area, and then everything else connects underneath. But if it's a single area, it could have been any area. It doesn't have to be area 0. So if I had a single area, I could have called it 10 and it would be fine. It's just when you connect two different areas to each other, it works on a hierarchical structure. Clear? So we did that. The ABR contains the complete database of all the areas that it belongs to. Hence, requires more memory and CPU. You guys okay with that? Do you understand why do I need more memory or more CPU utilization or more powerful CPU on the ABR? Because it will house multiple databases. It's not a single database. It'll have complete information from both areas. It will have two databases. Type 3 LSA will only leak one route, the most common among them. No, that's wrong. That is wrong, Delano. What I said, it's the same route, same LSA, but you'll have multiple instances of that. So for example, in my topology, R1, R2, R3, and R4, all four were advertising the same route. I have a link on the 100 network. So in my LSA database, I will see a type 1 from R1 saying I'm connected to 100. R2 will say I'm connected to 100. It's the same network. R3 will say I'm connected to 100. So if you really look at it, in your database, in your LSA database for type 1, you will have 100 listed by R1 as a link, as a type 1. Same network, it's not a different network. R2 will type 1. He will list it up as a type 1. R3, because he's also connected to it, will list it as type 1. And R4 will list it as type 1. All four will list the same network because they're all connected. All right. Plus, you'll also have another LSA in the same database for type 2, which is done by the DR, whoever the DR is, which will list that R1, R2, R3, and R4 are four routers on this multi-access segment, and this is your type 2. Now, how many instances of 100 do you see in your LSA database within your network? You have 100 listed 5 times. So the summary LSA will not send the network 100 5 times. It's going to send one instance of 100. So he's going to say 192.1.100.0. If you want to get to it, send it to me. It's not multiple networks. It's the same network, common network that you're going to summarize. That's why it's called LSA summarization. You're summarizing multiple LSAs for the same network, common network. Does that make sense, Delano? So for every single network that you have within your area, you will send one type 3 LSA outside there. Not more than one, just one. You do. Common network meaning what? You see, this is one common network 100. If I had a topology like we had the last time round, remember the multi-access networks. Remember we had R6 and R7 to it. Let's say this is my ABR. This is area 0. R2 is my ABR. So what does R2 do then? R2 is in his database, in his LSA database, he'll have 100 listed 5 times. He'll have 200 listed 4 times. But what is he sending over here? 100 once, 200 once. For every network, he's going to send one LSA. But every network will be sent out by default. You get my point? That's why it's called LSA summarization. Do not confuse it with route summarization. Because I will have multiple LSAs for the same network. All right, cool. So coming back over here, hence requires more CPU and memory on the ABR. It injects a single LSA for each network within the area. Although that same network might have multiple what? Type 1 and type 2 LSAs. This is known as LSA summarization. You guys good with that? Clear? All right, so with that in mind, let's go ahead and set this up. Let's start with R2. We'll just connect the links up. I'll put network addresses over here as well as we're going along. This is going to be the 24 network. All right, sorry, that was going to be 12. This is going to be 23. This is 24. Yeah, this is 12, 23, 24. Similarly, we'll have 35.0. And I'll keep a bunch of different loopbacks over here on each router. This one will be 46. $78. All right, so let's set the network up over here. We'll start with router 1. I'll do it in Notepad. Makes it easier. En config T, interface loopback 0. This is router 1. This is that EIGRP network. Let's say 201.1.4.1. To create a bigger network over here, and I also want to use this for something else later on. 4 is good enough. Five, 6, 7. Interface F0/0 or S0/0, sorry. And let's run EIGRP over here. To make it simple on myself, I'll say anything that starts with 201.1. Copy this. We'll go to router 1 and paste it. Is it possible to have 2 ABR in area 1 to connect to, say that again, have 2 ABR in area 1 connect. 2 as in 2 number 2? Yes, you can have for redundancy. So you want 2 ABRs connecting 0 and 1 together? Is that what you want? For redundancy, you can absolutely have that.
So 2 ABR in one area connect to another area, both going to the same area.
Yeah, you can have that for redundancy. So both ABRs will inject the routes into the same area. Basically, what you're saying is this, if I'm understanding your question correctly, is you have area 0, for example, over here. You have one router over here. You have this type of setup. Is that right? So this is an ABR between 0 and 10, 0 and 10, right? Is that what you want? Yeah, absolutely. This would give you redundancy. So both the ABRs will inject the route, then the routers over here will find the best route to get to the ABR and reach it. It takes a look at the cost and sees which is the better cost to get there. Yeah, it can be done for redundancy. All right, let's do router 2 now, network 2. Router 2, network 2. I don't need to create the loopbacks over here. We'll keep them for later. But I do want to have loopback 1 over here, or loopback 22. I'm going to be advertising this loopback in OSPF. So if I don't do IP OSPF network point to point, if you remember, it will send that route as a /32 route. I want to see it as a normal network. IP OSPF network point to point. We'll take the interface mask and we'll keep it as the default. S00 will be 12.2, plus I will also have an interface for F00, which is 23.2. All right. No shut. Interface F01, which is 24.2. 2 to 4. I'll show you the topology in a sec. Now, in terms of EIGRP, I'm going to advertise the network 2 to him. The rest, I'm not going to advertise. I'm going to run them in OSPF. Router ID, let's say 2.22.22.22.22. Network 23.0. Area 0. 24.0. And network 22. All right, so should be okay. Copy it. Let's go over here to router 2 and paste it. I should at this point have an EIGRP neighbor relationship up. There you go. And the routes are popping in from R1, the EIGRP routes. R2 is also connected to OSPF over here. Now we're going to do the rest of the OSPF network. We'll start with R3. R3, I'm going to have 2 loopbacks. 3, 33, and again, the loopbacks in OSPF, if I don't do that, I'll show the /32 mask. I want to show them as normal networks. I don't have a serial interface on R3. I have this guy, which is 23.3, and I have this guy, which is 35.3. I don't have EIGRP at all. This guy changes to 33. 23 is in area 0. I have 35, which I will keep in area 10. 22, I don't have 22. I have 33. I'll keep it in area 0. And I have a 3 network, which I'm going to inject into here as 10. So that should finish my R3 router. Now OSPF is a little slower in terms of convergence. So even though the route comes in the design, it complicates it, but just to give you an idea, I'll just write it down for you. It puts too much stuff on here. This is S0/0, F00, F01, F00, F00. Connecting inside is F01, which connects to F00. This guy over here, F01, connects to F00. F01 connects to F00. This is obviously serial. Clear? All right, so 3 is done. I should have some routes over here for router network 3. OSPF routes, I have 1, the 22 network. I haven't gotten the edge RP route because I haven't done redistribution on router 2 yet. We will do that in a bit. Let's set up router 4, which will be very similar to router 3. Just change these. That's why I try to do it in Notepad. Makes it simple to just edit and paste rather than doing the whole commands by themselves. The first network, which is towards router 2, is 24.4. The second one is between 4 and 6. So I'll say 46.4. OSPF. This is going to be 24, which is in 0. This is 46, which I'm going to put into 20. This is 44. This is 4, which is in 20. This is going to run for 6 hours total. 1 hour is gone. So you have another 5 hours. So copy this. Go to the AV. Now you'll notice that I haven't done anything special on R3 and R4 to make it an ABR. As long as it has links in 2 different areas, it becomes an ABR. So you don't need to designate, oh, I am creating an ABR. As soon as the router has 2 links, one in one area, the other one in the other one, it automatically becomes an ABR. So you don't need to do anything special about it. Good? So 1, 2, 3, and 4 are done. Now the next thing we do is the internal routers in area 10 and 20. So we'll start with 5. 5, I'm going to keep those other loopbacks as well. I'm going to have these. I'm going to also add some more, but before I do that, let me put the interfaces over here, 35.5. I don't have this. .35, which is in area 20. This is in 20. I don't have this one. I have 55. I have 5. Plus, what I'm going to do is I'm also going to create these. Some loopbacks that I'm going to use later on. I'm just going to change this to 205.